Okay, so we are going to talk about quadrature, what is another name of numerical integration. So first, we consider the simplest quadrature rules, what is a trapezoidal rules. And trapezoidal rules is, you approximate the area under the curve by the area of a trapezium under the curve. And now the question is, suppose I have this formula for one trapezium already. How can I derive the composite rules when I divide the area under the curve into n equally spaced trapeziums? So let me draw pictures. So the pictures look like this. So suppose your curve is like this, A to B, and you try to find the area under the curve, and you do it by cutting it into equally spaced trapeziums, yeah, and then you approximate the area under the curve by the sum of the area on the trapeziums. So now suppose I have n subintervals, yeah, so I label the first point will be x0, okay, according to this formula. So x0 is at the point A, at the left point, and at the right point I label this one is x capital N. Okay, so now what is the width? So the width of the subintervals is h, and it equally spaced, so every trapezium has the same width. So now what is the area of the first trapezium? So the area of the first trapezium will be so the area of the first trapezium will be of the first trapezium so it will be the height, yeah, so it will be the height, so it will be 1/2 h times the height with fa, which is fx0 plus f of x1. Okay, and then the area of the second trapezium is 1/2 h f of x1 plus f of x2, and so on. So then you can have the last trapezium, so the area of the last trapezium is 1/2 h f xn minus 1 plus f of xn. Okay, and when you sum it up, so now the sum, when you sum it up, then you can say that the area under the curve from A to B will be approximately by the sum of the area of all the trapezium, so it will be 1/2 h, and then you have fx0 plus fx1, but then you have fx1 here as well, so 2 fx1, then 2 fx3, sorry, fx2, and so on, up to the last one is 2 fxn minus 1, and then the last term is only one term, so plus fxn. Okay, and when you rewrite this formula, it will give you exactly this formula. Yeah, so because remember fj is f at xj So then this formula is identical to this formula. Well, when you take the 1/2 inside, then you get this formula.